Today's lesson is about isosceles and equilateral triangles. First, let's talk isosceles. Remember, isosceles has two sides that are congruent to one another, tick, tick. And we call those two congruent sides the legs. The one that's not congruent to the other two, we call that the base. And then there's names for the angles too. The two angles that are down by the base are called the base angles. And then that angle up at the top where the two congruent legs meet is called the vertex angle. On the flag from American Samoa, we have an isosceles triangle. You can see that these two sides would be considered the legs. This side would be considered the base. Then our base angles would be here and here. And our vertex angle would be this one where the two congruent legs connect. The reason it's important to be able to name those sides and angles is because of these two theorems. The first one is called the base angles theorem. If two sides of a triangle are congruent, so basically if you have an isosceles triangle, then the angles opposite to them are congruent. So I have a picture down here. If you have this isosceles triangle, if you look at the angle that's opposite those congruent sides, so the angle that is not even touching the congruent sides, that's the base angles, right? So the theorem says if we have those two congruent sides, then we can say that those base angles are congruent, that angle B is congruent to angle C. And what do you know, the converse is also true. If you find a triangle that has two congruent angles, then you can say that the sides opposite of those are also congruent, which means you've got yourself an isosceles triangle. And that's what I've been saving those last two theorem spots on your pink sheet for. So the first one, will you write base angles theorem? And then just draw that little picture, maybe the if part, being that if you have an isosceles triangle, then what can you do? Then you can say, swoop, swoop, those base angles are congruent. And then the converse just switches the if and the then. If you see a triangle with two congruent angles, then you can say that you found an isosceles triangle. Let's try this out on an example. So this first one says if HG is congruent to HK. Let's find that on the diagram. HG is congruent to HK. So I think they're telling me that this triangle right here is isosceles, right? So if I use the base angles theorem, then I can say that this angle G and this angle K are congruent to each other. Angle G and angle, I guess we'll need three letters for this one, HKG, are congruent to each other. And since I went from the congruent sides to the conclusion that the angles were congruent, that tells me I was using the original base angles theorem. All right, the next one says angle KHJ. KHJ is this angle right here. Angle KJH is this angle right here. So it looks like the triangle that they're talking about is this triangle in here this time, right? Might need to turn your head a little bit. If we have those two base angles congruent, then I can say which two sides of that triangle are congruent? This one and this one, because this would be the base of that triangle, sort of turned upside down. So I can say that HK is congruent to KJ. And that time I started with those congruent angles and I concluded that I had myself an isosceles triangle, so that was the converse. Since the base angles theorem is a theorem, we can prove it. We can say that if we have an isosceles triangle, then those base angles are congruent. And we won't be able to use the base angles theorem as any of our reasons in this proof because we're trying to prove that this theorem even works in the first place. So I'm talking about this full triangle JKL, as being my isosceles triangle. But just to help the proof out, I dropped this line from J to M where M is the midpoint. So nothing special about that line other than it just got drawn to M, which is the midpoint. So those are my givens. I have JKL is isosceles. And what does that mean? What is the definition of an isosceles triangle? Well, since they told us that this was the base, then I could say that the JL and the JK are congruent. That's what it means to be an isosceles triangle, that you have two congruent sides. So that took care of my first given. That's why I love these flow proofs. It really helps organize my ideas. I've got M being the midpoint of that base. So if M is the midpoint, I can say that LM is congruent to MK by the definition of a midpoint. Now I've used my other given. And they're sharing a side, so I can use the reflexive properties, say that JM is congruent to JM. And really what I've done here is I've set myself up to prove that those two smaller triangles are congruent to each other because I've got three sets of congruent sides on them. So being careful about the order that I put those in. If I call the first one JLM, I'll call the second one JKM, putting those points in corresponding order. You guys, now that I know that those triangles are congruent to each other, I can say that all of their corresponding sides and all of their corresponding angles are congruent. And so I can hit my punchline that angle K from this triangle and angle L from this triangle are congruent to each other. And those were my base angles of that big triangle. So I just proved the base angles theorem will always work. And I used a little CPCTC. I'm thinking that you probably already knew about this. Did you know that equilateral triangles are always equiangular and equiangular triangles are always equilateral? I could draw those same little if-then pictures for these two theorems. If equilateral, then equiangular. If equiangular, then equilateral. One other thing that I wanted to point out, which maybe you've realized this too, is that if all of these are the same measurement, we'll call them x, x, and x, then if I add all of those together, they have to equal 180 by the triangle sum theorem. And 3 x's added together mean that each x would have to be 60 degrees. So every equiangular triangle is going to have 3 60-degree angles. That doesn't mean that their sides will measure anything related to 60 inches or centimeters or anything. It just means that all three angles will be 60 degrees each.